Yeah, we're going to review, but we're going to start with that 4-4 homework because, peeps, there was some real, like, not good stuff going on there. So we need to get that figured out. So, all right, so, everybody paying attention now. Next time we have class, we have a quiz over all of this stuff. All right, so the first one I want to do is the very first one. Now, again, I apologize. Some of you got some of these right. So you're going to have to sit through it because I'm going to pick out the ones that a lot of people didn't get right. And number one was one that a lot of people didn't get right. So, whoa, look who decided to come to school today. Thank you. All of you, good to see you back. Okay. Now, I am going to plot some points on here. And you better pay attention because this is on your semester exam, a question like this. So you need to be able to do it. Not only that, you're going to take a quiz on Monday that has this on it. All right, so here we go. I'm just going to plot some points. Now, it says in here, 36 is the minimum value, and 79 is the maximum value. All right, I could probably got that from the chart, but it says that right there for me. So, I'm going to plot some points. I'm going 1 through 12. All right, so here we go. At 1, so month 1, I'm at 36. At month, where am I? So at month 7, I'm at 79. And at month 12, I'm back to 36 again. Now, I'm not going to plot all the points, but hopefully you see something like that. Right? So let's just stop. What shape is that? Now, could it be a sine? It absolutely could be. But why would I mess with that when it's absolutely a cosine picture, right? So my equation is going to be something cosine something, x minus something plus something. Because I know that when I write a trigonometric equation, there are 4 adjustments that I can make to it. I can adjust its amplitude, its period. Now this number is not the period, but this number influences the period. Its horizontal shift and its vertical shift. So whatever equation I come up with has to have all those blanks filled in. And the order you fill them in doesn't matter. But I can tell from the situation that this is my new axis. In other words, the x-axis has been lifted up to here because that's what I'm oscillating across. So what is that red line? Well, it is the average of these two, isn't it, right in the middle? So when I add these together, I get 115, and 115 divided by 2, oh, this is too much, 57 and a half. Yep. That is my vertical shift. The picture has been lifted 57 and a half. We're now oscillating across that axis, and we're supposed to be oscillating across this axis. Now, this distance right here is the amplitude. So how far is it from 79 to 57.5? 21 and a half. So my amplitude is 21 and a half. Amplitude, think of it as the height of the wave, or half the distance from the top to the bottom. Half the distance from the top to the bottom. That's amplitude. Okay. Now, in a perfect world, cosine curve starts on the y-axis. Think of your BFFs. Isn't that where it starts? Oh, wait a minute. This one appears to be upside down. So that 21.5 is going to have to be negative because the picture is upside down. And it's not starting on the y-axis, it's starting over 1. So my shift is 1. Guys, I can't help you. If you can't remember, or if you don't know that that's what a negative cosine curve looks like, you gotta get that figured out. You need to know that. That's a negative cosine. It's an upside down cosine. And look where it starts, right on the y-axis. This one doesn't. This one shifted over 1 unit. Now, what's the period of this function? 12. So here I am. The period's 12. I have no idea what that number is, but I know that if I divide 2 pi by it, I will get the period. That's how you find the period. Your book, if you're looking at your book, or maybe some of the things I've cut and pasted, calls this B. I call it whatever you want. It doesn't matter. This number impacts the period. It divides the period, and the period's supposed to be 2 pi. So 2 pi divided by that number is 12. So 12n equals 2 pi, and it looks like that number is pi over 6. There is your equation. That's it. That's all there is to it. Okay, so now let's turn the page over and look at problem number 4, or 3, no, 4a goes to 3. It is the same exact kind of thing, except backwards. Now you have all of the changes, and you're going to draw a picture of it. So first of all, it's a sine curve, right? So I gotta know what a sine curve looks like. Is this thing running? It's a positive sine curve. Yep. It's a positive sine curve. So I'm just gonna sketch it to myself up here, give myself a reminder, this is what it's supposed to look like. That's what a sine curve looks like. Not this one though, because this one has been shifted pi over 2, or pi over 4 to the right. So it's gonna start here. I'm gonna hold off on that for a second. On that for a second. Or you know what? Why don't we go ahead and just put our new axis in? There's our new axis. Aren't we lifting this whole picture up 1? Just like we lifted this one up 57.5. So the point that was there is now going to be there. And here's going to be my picture. There it is. There's my sine curve. Now, the amplitude of this sine curve is 2. Now I'm starting at 1. So I'm going to go up to 3 and down to -1. Did everybody agree with that? The period of this guy is 2 pi divided by 3. That's his period. 2 pi divided by this. Well, that means that the distance from this dot to this dot is 2 pi over 3. I've got some fraction stuff going on. This is 3/12. The period is 8/12. So my end point has to be 11/12. And then right here in the middle, where the hill ends and the valley begins, is the halfway point of 3 and 11. So 3 plus 11 is 14, divided by 2 is 7, so this is 7 twelfths. The maximum, the high point, is halfway between 3 and 7, so that would be 5 twelfths. And then the valley, the low point, is halfway between 7 and 11, so that would be 9 twelfths. Done. Okay? That's not hard. If, by chance, this had been a cosecant, then we would do exactly what we just did, right? And then remember what you do if it's a cosecant? Put in the asymptotes and flip the curves. That was on this homework. Okay, now last one we're going to do here before we start our review is number 5. Where you have, it's just like this one, except the picture's already drawn for you and you're going to write an equation for it. So, alright, so here we go. I'm going to write a sine equation and a cosine equation because this thing could be either one. So when I look at it, I immediately see a cosine. Do you? Isn't that another negative cosine shape? But it could also be a sine if I looked at a different piece of it. But let's get some of these numbers filled in first, and then we'll do the sine. All right, what's my amplitude? 2. Is that going to change if I think of it as a sine? No. Now, I've got it. This is a negative cosine curve. I may have a negative or a positive sign. I'll just have to wait and see. But I know that number is a 2. What about my vertical shift? Look, we're going between negative 2 and 2. Do I have a vertical shift? Well, it's 0, right? It's 0. You have to be careful how we say, because like the tangent has no amplitude. So when you're asked for the tangent amplitude, you say none or empty set, right? When you're asked for the vertical shift of this picture, it's 0. Do you see the difference? It exists. It just happens to be 0 in this case. So use zeros if you mean 0. Use none if you mean it doesn't exist. Okay. Now, if this is a cosine, which I said it, that's what I think. Where am I starting my picture now? I'm starting at negative pi over 7. So doesn't that have to be positive pi over 7? And now I need to figure out this number, which controls the period. I know that my period is 2 pi divided by this number right here, whatever that number is. Well, what is my period? I'm going from negative 3/21ths to 13/21ths. How far is that from negative 3 to 13? 16/21. So 16 pi over 21 is my period. So I'm going to cross multiply and solve that. So 42 pi equals 16 pi n. So 21 over 8. And that's what's going to go right here. 21 over 8. Now, what if I want to think of this as a sine curve? By the way, on the exam, we tell you which one. So we're going to tell you, write cosine or write a sine. What we're practicing. So sine. If I'm thinking of this as a sine curve, I do not want to start here. Don't I want to start here? Doesn't this look like a sine curve? Now, That does not change the amplitude, it does not change the period, it does not change the vertical shift. The only thing that changes is maybe the sign, and that would be a positive too, because I did a hill and then a valley. But this is gonna change, because this determines which chunk of the picture you're considering. And this time, I'm considering minus pi over 21. Now, those are the two that come to my mind when I look at this picture. Are there other possible answers? Infinitely many. Because could I start here and look at this part of the curve? That would be a negative sign with a phase shift of 3 pi over 7. Could I start here and look at this part of the curve? Yep, that would be a positive cosine with a phase shift of 5 pi over 21. This is a grading nightmare. There are infinitely many. But what do they all have in common? That number, and that number is the same. This will change depending on where you started. And that sign will change depending on where you started. Okay? All right. Okay. All right. So set that aside. If we have time, we can look at some more of them. And we've got a full review sheet I gave you the other day, didn't I?
Sure.
Yes, I did. I handed them out. If you don't have one, go find one. Or look at your neighbors.
Do you have an extra one?
They,
In the back.
back in the back, if there are extras, they're back there. Now, this has way more problems than the quiz does, okay? Please understand, this has way more than the quiz. So, you're probably only gonna have to do like one of each section. I just put extra practice on there, okay? Did anyone happen to look at this last night? Of course not. All right, so, number 5, yesterday, let's look at number 5 real quick because we kind of shortchanged that yesterday. We ran out of time. We wanna make sure it's very easy, it's probably the easiest thing. We wanna make sure we're all on target. So I'm gonna do the second one in number 5. Our question is, find the period and identify if it's a sinusoid or not. So, step 1 of that determination is to find the period of each piece of the problem. How do we find the period of a trigonometric function? We take the normal period, which is 2 pi for a sine and cosine, and divide it by that number. So the period is 2 pi divided by 4/3, which is 2 pi times 3/4, which is 3 pi over 2, is that right? Yeah. Okay. Now, what's the period of the other one? 2 pi over 2, so that's going to be pi. So, not a sinusoid, right? Because what did we say yesterday? If it's going to be a sinusoid, then the two pieces have to have the same period. Obviously, these don't. Now, what does it mean to have a period of 3 pi over 2? Well, it means every 3 pi over 2, you repeat, right? So the curve starts over again, that curve starts over again every 3 pi over 2. That one starts over again every pi. What's the first number that's in both lines? 3 pi right there. That's the first one that's in both lines. And so what's the period of this whole thing? The period of the sum is 3 pi. Yeah. Okay, that's how we do that. That got shortchanged. Everything else we did all the notes for. So, what do we need to do? Let's just pick one from each section. So what one do you want to do in number 1? There's sine, cosine, tangent, cotangent, secant, cosecant. What do you want to graph? Which one?
The hardest one.
None of them are hard. F. All right, so F. Now be careful on this. The first thing you need to do is what? Take out the 1/2. Very good. Take out the 1/2. Remember, factoring is division. So dividing by a 1/2 is like timesing by 2. So this is going to be pi over 3. And if all that went too fast for you, 1/2 times that has to give you that. Does 1/2 times the third give you 6? Yeah, I'm all good. I'm all good. Now it's ready to graph. Okay. It's a cosecant. You will develop your own style, but I always graph a sine first. So I'm going to think of this as a sine. So in my blue pencil, I'm going to graph a sine curve that has an amplitude of 1/3 and a phase shift of pi over 3. So it's a positive sine curve with an amplitude of 1/3 and a phase shift of pi over 3 and no vertical shift. So right there. Now, what's its period? The period is 2 pi over 1/2, which is 4 pi, or 12/3. Might help me to think about it as 12/3, because I'm starting at 1/3 and traveling 4 pi. So where will that put me? 13 pi over 3, yep. Right in the middle of those two is the average of 1 and 13, which is 7 pi over 3. And then right in the middle of these two is the average of 1 and 7. And similarly, the average of 7 and 10, or 7 and 13 is 10 pi over 3. Now, that, if this had said sine, that would be the answer right there, okay? But it doesn't, it says cosecant. But that's real easy. Anytime the sine is 0, that is, has a 0, crosses the x-axis, x-intercept, its reciprocal is going to be on the line. So I'm going to have an asymptote. It cannot be a vertical asymptote. And then, start flipping these guys, and there we go. There is my cosecant. What is the amplitude of that picture? Amplitude. No amplitude. Does the sine, does the blue one have amplitude? Yes. Cosecant does not. Now, I'm not saying the 1/3 isn't important. The 1/3 is still a component of the graph, but it is not the amplitude of the curve. We already figured the period. The period was 4 pi, which means the frequency is 1 over 4 pi. Our vertical shift, we said we didn't have one, but our phase shift was pi over 3. All right?
And on that vertical shift, are you meaning that as 0, correct?
Yes, that is a 0.
Okay. And that's how we should write them if we don't
Yes.
have them.
Yes. Well, not this one. This one does not exist. There is no amplitude. The amplitude isn't 0. there isn't an amplitude. So that's the difference between that answer and this answer. Okay. All right, let's graph real quick. Let's do, secant, cosecant will be done, or secant and cosine will be done the same as this, just a different shape. So let's do, 5, y equals 5 tangent 3/4 x. Now, first of all, just as a reminder, what does a tangent look like? A tangent has an asymptote at negative pi over 2, positive pi over 2, and looks like that. That is your regular tangent. Now, what have we done to our tangent? Well, let's talk about that. We have changed its period, clearly, right? Because we put a coefficient on x. What is the normal period of a tangent? Pi. So now when I find my period, it's pi divided by 3/4. Remember, to calculate your period, you take what should be the period, the normal period, and divide it by that coefficient. Well, the normal period's pi, so I'm dividing by 3/4, which is 4/3 pi, multiplying by 4/3. Now that means that from asymptote to asymptote is 4/3 pi. So where are the asymptotes?
5/3, -2/3.
Negative 2/3 pi and positive 2/3 pi. That's where they are. Because asymptote to asymptote is a period. And you know that the period's 4 pi over 3. It's a positive tangent, in it goes. Now there's the picture. I know what's on your mind now. At least I know what I'd be thinking if I were you. This 4. What about 5? What about that 5? The 5 actually makes your curve steeper. So, you know, like this would be a really curvy tangent, and this would be a steeper tangent. And the 5 impacts that. But in terms of labeling anything or anything like that, the 5 doesn't have an impact because a number in that position would multiply the amplitude, right? We don't have an amplitude, so it doesn't show up. When you start listing all this, that 5 doesn't show up. It does impact your curvature, but not when I'm graphing on notebook paper. So basically you can ignore it. Unless it happens to be negative. Because a negative would have a visual impact, right? A negative would turn it upside down. Tess? Tess? The normal tangent has a 0 at the origin. Same distance both sides. And if the whole distance is 4/3, then aren't we gonna have to go 2/3 in each direction? Yeah, yeah. All right, so we'll stop there. When you come back, we will do one and more of each section. And then in the meantime, if you can think of something else, we can do that too after lunch. Be back at 50. Back at 50, in your seats, ready to go. The only time the spaceship exists, can I have a tangent curve with spaceship? Yeah, there you go. You answered your own question. If you can have it, but you don't, then it's 0. Can't have amplitude. You can always have phase shift.
Okay, so you can always have it, so it's
Yeah.
either a number or
Yep,
0.
yep. Phase shift and vertical shift, yes, always.
Either.